Today we will discuss the topic MapReduce, MapReduce components, MapReduce framework, working of the MapReduce, logical flow of data in the MapReduce, and examples of MapReduce. MapReduce engine, what is the MapReduce engine, and the MapReduce workflow, how it works, and at the end we will discuss the MapReduce advantages. So first question is that what is the MapReduce? So before understanding the MapReduce, we have to know the Hadoop and the Hadoop components, or you can say how the Hadoop works. So in the Hadoop, basically it is a Hadoop is an open source Java based programming framework, and it supports the storage and the processing of extremely large data set in the distributed computing environment. In the Hadoop, just we can see with the help of this Hadoop. In this one, there is a data ingestion, data storage, and data processing, and data visualization, analyzing or visualization. So these are the different parts of the Hadoops. It means data ingestion, data processing, storage, data processing, and the data visualization, and before you can say analysis of the data also. So basically data is stored in the HDFS. HDFS data is stored the HDFS. And the data comes from the various sources. What are these various sources? It means you can say that data come into the format in the shape and different shape and size in a form of structured, semi-structured, and unstructured data. So first we can see that the data is come from the various sources in the form of structure, semi-structure, and unstructured. This unstructured, structured, semi-structured, and unstructured data is stored in the HDFS. HDFS is nothing but it is a Hadoop distributed file system. And once the data is stored, then there is a requirement of the process. So for the processing purpose, the MapReduce is a tool, we can say. It is a data processing tool which is used to the process the data parallelly in the distributed form. Parallelly in the distributed form, meaning just let's see. Data parallelly in the distributed system. As we know, in the HDFS, the data is stored in with respect to the name node and the data nodes. So name node basically or you can say the master node is coordinate the all the data nodes. So data node, actually data nodes, they are different data nodes, data nodes. These data nodes basically the commodity hardware where the data is actually stored. The word is commodity hardware is nothing but it is a computer systems which are available as per the requirement on the various locations. So once this name node having the metadata or the links of these data nodes. So this is a formation where the data is stored. But now how the data is processed. So for processing of the data, because it is a simply on the network, this is a commodity hardware or the computer system is exists where the data is stored. We require the processing. The processing in a, if we understand a computer system, the processing is work as you can say that whatever the data is required to the process that comes onto the RAM, all the data on the secondary memory, and that process, and once that process is complete, the resultant is stored again the secondary storage. But here there is a huge amount of data. It is a large data which is stored in the various commodity hardware, and if the processing is required, then there is a one way that you can call the all the data on a particular place or the particular system and process it. But it will be a very big task, it will be a challenging, because the system are on the network, and once the data is come onto the system from the various data nodes, then there may be the problem regarding the bandwidth. The bandwidth issue may be possible, and there is a not a single platform where the data can be processed. So this is again another challenge. To minimize this, that is the data parallelly as is distributed and with respect to the parallel programming. So parallel processing, it means parallel distribution. It means here the data is processed on a single machine, and whatever the resultant that come onto the one place or the name node, and that collect the resultant of from the various data nodes and process and provide the resultant. Now main components of the MapReduce. So MapReduce components, there is a two MapReduce component. One is the map and the second one is reduce. So map is nothing but mapping the data or the contents which come as a input to be processed, and reduce, it minimize in a form of that data after processing. Next, the MapReduce framework. The MapReduce framework developed and maintained by the Apache Hadoop project and are implemented in form of the Hadoop MapReduce. MapReduce is based on the parallel programming framework to process the large amount of data. As in a previous slide, I have described the parallelly distributed formation. Here it is based on the parallel programming framework, parallel programming framework as a large amount of data. Name node or the master, data nodes, I'm not describing the detail of the HDFS because HDFS is another topic where in detail we can discuss, but here only just brief I am giving to understand the MapReduce framework. In this one, that is data is actually stored in the data nodes. These are the data nodes. Now, the parallel programming means the data is not, the huge amount of data is not processing at a one place or a one computer. It is processed on independently on the different data node or the commodity hardware, prepare a result, and that resultant give to the name node or the master node, where it prepare a combined result, and that result is a complete processing of the data processing result. In another word, we can say, suppose to the huge amount of data is required to be processed. In that case, the data is existing on the different data nodes or then the commodity hardware. Wherever the data, partial data is exist, there exists a Java program that process it, prepare a result, and return to the partial result to the name node, and that combine that all the result into a single result. Next one is MapReduce facilitates the processing and analyzing of the both unstructured and the semi-structured data collected from the different sources. Yeah, it means that is the data is the unstructured, semi-structured, or structured. Now the question is here, what is the unstructured, semi-structured data? As we know, the big data is a form of a semi-structured, structured and unstructured data. Unstructured data, like that you can say that data is come from just like the data, Facebook data, video, audio, sensors, different smart watches or the smart machines, where the data is generated, where there is no such kind of the format where the data is coming in a particular format. There is no such kind of format. But in as compared to the structured data is a simple as a schema based data, where format is already defined and decided, and that kind of the data is a structured. But here the unstructured, where there is no such kind of the format that can be stored or that can come from the different places. It means data is unstructured, semi-structured data collected from the different sources. The sources are unstructured or semi-structured. Unstructured sources is Twitter is audio, video, Facebook, messages, sensors, and just you can say PDF files. All kind of such data is unstructured. Where the semi-structured, we can say the log files or CSV files, XML and JSON files are come into the semi-structured data. The next one is the MapReduce framework. It algorithm contain the two important tasks. One is map and the second one is reduce. So map task and the reduce task. Map task is set of data convert into the another set of data, and where individual element are the broken down into the tuple key pair values. We will understand this in detail with the help of an example. Secondly, reduce task, which takes the output from the map and the input combines these data in tuple into the smaller set of tuples. Now step by step we see the working of the MapReduce. Take a large data or a set of data, then perform iteration over the data, extract some inciting interesting patterns to prepare the output list by using the map functions, arrange them as a output list properly to enable optimization for the further processing, and compute a set of results by using the reduce functions. Provide the final result. So these are the steps where from the beginning to end it take a input, split the data, map the data, shuffling and sorting the data, reduce the data, and finally provide the output of the data. With a logical form, we can see this input split the data input, split, map, shuffling, sorting, reduce, and output. What are these? If we see this one, input data from the various sources. The data is unstructured and semi-structured. That data is split with respect to some kind of interesting to be processing whatever we want to the process the data in a form of split that data. And let's we take an example. Suppose there is a text file, because data may be the different format. These text files having the information about the companies or employees. Statements are written here, and these statements are 1, 2, 3, 4, 5, 6 and so on. So with respect to the input, that data is split in, suppose to we are taking the line by line. One line, it is a one format. second line, third line, fourth line. So it means split into the different lines. Now the map function break up into the key value pair values. Key value pair. So here there is a key value pair. So the data is break up or split with the help of key value pair. So key value pair, it means here if we see this data 1, 2, 3, we can understand a line is representing with a single number is a 1, 2, 3. So this can be say these are the keys, and with respect to the line the statement is a value. So this is break up into the key value pair. Now it break into the tokens. Again it break up into the key value pair tokens. Then whatever the token is generated, it creates the list of this token, and then it's shuffling and sorting that tokens. These are converted into the as a reduce. It means now the whatever the tokens which is converted into the list, and that list is reduced in the form of token key value pair, it means tokens, and finally it produce the output. Slightly it is looking as a complex, but with the help of example you can understand this easily. Let's we see the example. I'm skipping this one. Here mapping and reducing, there are two forms. It means input. Here the map functions, there may be the different map function may be, and reduce function and the output. Okay, let's we see an example. With the help of example you can understand easily. Example 1, this is a one example which is a map reduce example. Here you can see this is a input. This is input. Here the word statement is written deer, beer, river, car, car, river, deer, deer, car and beer. Suppose this is a data which is required to map reduce data processing as a with the help of the map reduce. So these are the statement, the first statement, second statement and third statement. This break up or split into the three part with the help of the key value pair. Key value, because map reduce function the work in the key value pair formats. So here the first line, second line and third line is break up or split into the three different forms, and the first one is a first line, then it break up the second line and third line. The first line tells about the key value pair. Now what is the here key and what is the value? The line number 1, 2, 3, as I have discussed in my previous slides, that is data is numbering. So numbering is the key and the rest part as a statement is a value. But here that numbering is not, that all the values as a key values represent with the hexadecimal value. So hexadecimal value, it means if this is start from the 0, then this is a key value for this statement. And next key value, how it will be generate the next key value for the next statement? 0, D1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And there are 15 characters. The 15th, the 16th position will be the key value in a hexadecimal. As a hexadecimal, it means that is converted into the hexadecimal value, and the rest one is again the rest part is again the value. In similar, there will be a key and the rest part will be the as a statement is a value. Now this splitting is completed, and how this splitting done? With the help of the map reduce function. And generally the programmer make a program to how to be split the data, because we have to do the processing that data. Now second step is mapping. Third step is mapping. It means mapping is again it creates the list, and with respect to the as a splitting data. So now it create the tokens and the value. The token is generated. Now this is create the tokens. How it means the line is break up into the words, and word is identified with a space. And with respect to that, it is creating a value. It means it creating the list as a key and a value. So key value is that now the deer is a key. Here the number is statement is the value, but here the word count as the mapping, which handle with the map function. The word is a key and the one count is the value. Deer, beer, river, deer, comma 1, it is a one list. Beer 1, river 1, it means it with the help of the map function it is making the list. The same as it is for this, same as it is for this. Now there is a requirement of doing this is the mapping with the shuffling and the sorting. Here sorting is also shuffling and sorting. Now the shuffling, again it create a key value list. And how the key value list, it takes the as a, because we know that the whatever the output of this, as it is input to the mapping, whatever the output of this, that will be the input to the shuffling or the sorting. Whatever the output of this shuffling and sorting, which will be in the reduce. So here the deer 1 deer, it means it will be the input to the as a shuffling or the sorting. So just before first we discuss the shuffling. So shuffling is the whatever the token and that value, it is will be the input to a single token. So here deer 1, it goes to the simple as a deer 1, it is one time it comes and create a one time into the list. The second one is again it creates, river is again it creates as a statement. The third one is a car 1, it will check is there exist during the shuffling, is there exist the same name anywhere? If yes, then it will add a one count more in the list, and the second count, third count if a token is repeated. So now this token which is here created by in the mapping, it create the a list of number of number of tokens. Okay. Now once it is shuffling, then there is a required of the sorting. Sorting is the very because it is in a sorted form. You know that that alphabetically it is sorted. That beer is first, car, deer, and so on. So here shuffling and sorting is completed. The next one is that is now it is reduced, and the reduce the simply count the tokens with the help of the list elements, and finally it reduce as the beer is 2. So here again there is a key value, and it combine into a one list, and that list is a called that list is called a final result of the map reducing with the help of the map reduce function. See the other example. Let's we see one more example. This is slightly complex. Here the statement you can easily see. This one is there is a one statement. There is a more statement is here basically written. Statement is this is a one statement. Hadoop is a big data framework. Hadoop can store vast data. Hadoop process big data. Hadoop can analyze and waste the data. And Hadoop is last one is Hadoop is easy. In the same manner as I earlier discussed, it will split in the form of as required, like this. Hadoop is a big data framework. This is a one split statement wise statement is breakup, and the next one is mapper phase or the mapping, where it generate the tokens. Tokens is nothing but it can be a word. It depends on what kind of data processing we are doing. It may be the different as per the requirement, and it mentioned in the program that is how that data will be the split, how the data will be the mapping, and the how data will shuffle and sort. This is a simply a programming as a code that executes in that manner. So here split is a simply into the statements, and statements break up into the tokens, and the token is a key, and the number of count is the value. It is mapper phase like that. Here there is a token. Hadoop is a token, and this token is a simply a key value, and count is a simply value. So here they are break up into the countings as a key value pair. Then the shuffling you can see this one, shuffling and sorting. So you can check this one. Is it in a sorting form? Shuffling is okay, but is it in a sorting mode? No, because sorting is that is sorting is the alphabetically may be possible, or the word wise may be possible. It depends. Sorting, and once it is completed, now here Hadoop is written, but in earlier example we have taken the one count on you can make the list and the count and simply reduce that one. Okay, let's take another example where there is a some kind of mistakes are done, and what are the mistakes we have to find. As we know, this is this is splitting. This